This is Unit 2, Lesson 5, Graphing Linear Inequalities, and the objective is students will be able to graph a linear inequality on a coordinate plane. Graphing a linear inequality isn't much different than graphing a linear equation. So we still follow y equals mx plus b. You still do the y-intercept, you still do the slope. There's just two things that are a little bit different. Before we get into the steps, let's take a look at the vocabulary. Our first term is half plane, and a half plane is a region containing all points that has one boundary, and this boundary is a straight line that continues in both directions infinitely. So if you think of the coordinate plane, and then when you draw a line on your coordinate plane, a half plane is saying we're dividing this coordinate plane in half and we're only looking at one half of it. Which this is kind of what your coordinate planes are going to look like when we graph the linear inequalities. So linear inequalities only represent half of a plane. Our next term is inclusive. Inclusive is a line or boundary that is part of a solution. So when we are graphing our inequalities, if you have the inequality less than or equal to or greater than or equal to, that means it includes the boundary line. So we would use a solid line to graph this. So the values could be any number smaller than it or any number bigger than it, but it could also include that number because of the equal to line. So solid line tells us it can include the line, the boundary line itself. The next word is non-inclusive. And as you can imagine, a non-inclusive inequality has a boundary line that is not part of a solution. So that's something like when we have less than or we have greater than. That's telling us that the values have to be less than the line or they have to be greater than the line. It does not actually include the line itself. So whenever we have an inequality that's less than or greater than, we use a dashed line to graph it. So it will look something like this on the graph. A dashed line that goes on forever in both directions. So let's graph a couple different inequalities. We'll do some inclusive inequalities and some non-inclusive inequalities. We're going to graph the linear inequality y is greater than x plus 3. The first step, the same first step we always take whenever we're graphing anything, is to solve for y. Make sure y is the only thing on one side of the equal sign or the inequality. So in this case, step 1 is already done for us. We can move on. Step 2 is to graph the line. Remember, when we graph the line, we're going to connect the dots using a solid line for an inclusive graph, and we're going to do a dashed line connecting the dots for a non-inclusive graph. So right now I'm looking at a graph that is greater than, which means it doesn't actually include the boundary line, so it is non-inclusive, so I'm going to be doing a dashed line on this graph. So let's start off by doing our y-intercept as always. In this case, m, the slope, equals 1 over 1, b equals 3. So my y-intercept is up here at 3, and then my slope goes up 1 over 1, up 1 over 1, up 1 over 1. Since it is non-inclusive, these dots are going to be connected with a dashed line. And I want you to do your dashed line going on forever, or as far as you can go on this graph. And we're going to do that because of the next step. Our next step is to shade the half plane. And there's a couple ways you can do this. I'm going to show you both ways because some people like one way and some people prefer the other way. So one way we can do that is by using a test point. And the other way we can do it is kind of just by some critical thinking, I guess we'll say. So let's go back to the graph and I will show you how to do each way. So the first way is the test point. If you are using the test point method, then you can pick any point on this graph as long as it doesn't fall on the boundary line. So just to be safe, I'm going to go far away from the boundary line and I'm going to pick the point right here. That is the point 2, 1. We are testing to see whether or not 2, 1 is included in this inequality up here. So in order to do that, we're going to substitute 2, 1 back into y is greater than x plus 3. Instead of putting y, we're going to substitute the y value, which is 1. Instead of x, we're going to substitute the x value from up here, which is 2. And then 1 is greater than 2 plus 3, which is 5. Now, ask yourself, is 1 really greater than 5? Well, no, 1 isn't greater than 5. 1 is less than 5. So this is false. If this is false, that means that this point right here, the 2, 1, is not included in the solution set. So we're going to be shading this graph. We need to shade the side that doesn't include this point right here, because this point, it's not true, it's false. This point does not satisfy the inequality. So we need to shade the other side that doesn't have it. So I'm going to grab my blue pen and I'm just going to shade everything over on this side. And this isn't a perfect shading because it's kind of hard to shade with this on this program, but you get the point. We're shading everything on the other side of the dashed line. So really it should go even closer up to the dashed line. That means any solution in the shaded area can satisfy this inequality. Any point on this dashed line cannot satisfy the inequality because y does not, it's not including, it's only greater than, not greater than or equal to. So this is the one way you can do it. Let's clear this off and look at the other method. So this is the way to do it by thinking critically. Our inequality is y is greater than x plus 3. So that means we need to shade every place where y is larger than this line. The line right here is x plus 3, and you can see it going up all the way. So I go to the y-axis and go to the point where this line starts, right here. And I'm asking myself, where is the y-axis greater than this point? If we go down, the y-axis gets smaller, which would be less. If we go up, the y-axis gets bigger, which is greater. So that tells me I want to be shading up along the y-axis. So I'm going to shade everything up that y-axis. You can do whatever makes more sense to you. If you prefer picking a random point out here and testing it to see if it works, that's fine. If you prefer just thinking about it, going to the y-intercept and asking yourself, should I go up or should I go down? that works as well. It's whatever is easier and more comfortable for you. So let's look at another example, and we will try another test solution and thinking critically again. All right, the inequality this time is y is less than or equal to negative 5x plus 7. My slope is negative 5, and I'm going to put that over 1 so I can see the rise and the run. My y-intercept is 7. So let's go over to our graph, and we're going to count up to 1, 2, 3, 4, 5, 6, 7. And now my slope is negative 5 over 1, so I'm going to go down 5, 1, 2, 3, 4, 5 over 1. Let's do that again. Down 1, 2, 3, 4, 5 over 1. And remember, on the last one I told you, the more you do, the better, because 1, 2, 3, 4, 5 over 1. When we draw our graph, we want to show it going all the way across. That just makes it a lot easier for when we do the shading. Okay, so here are all of my points. Now let's look over here at the inequality. It is less than or equal to. So it is an inclusive line, which means I am going to do a solid line this time rather than a dashed line. All right. Now, we can pick any point we want to pick to test. So let's test it right here. Actually, I'm going to test it right at the origin with 0, 0. 0 is usually a pretty easy number to substitute into things. So I have y is less than or equal to negative 5x plus 7. And I'm going to substitute a 0 in place of y and a 0 in place of x because my test point was 0, 0. So the 0 stays there. Negative 5 times 0 is 0. And I'm left with 0 is less than or equal to 7. Well, that is true. 0 is less than or equal to 7. So this time I'm going to shade the whole area that includes the test point. So we have two sides to this line. There's the side over here that includes the test point, and then there's the side over here that doesn't include the test point. I'm going to go for the side that does include the test point. So let's shade all of this area. That tells me that the solution could be any point in this whole area going on to infinity, or it could be any point on this solid line. Now, what about finding the test point by thinking critically? So check out the inequality. It says y is less than or equal to. So that means all of my y values need to be less than or equal to this line. They need to be less than. So let's go to the y-intercept. If we go up the y-axis, the points are greater. If we go down the y-axis, the points are the points are less. There we go. So I need to be less than, so I'll go to my y-intercept, and I need to do everything going down. So that means I will shade everything from this point down and all the way over. I don't want to cross the boundary line. If you're feeling pretty good about this, you can go ahead and stop the video here. I'm just going to do one more example. My last example is 2x minus 3y is less than 15. And I need to start this off by solving for y because I don't know how to graph things that aren't in this form. So I'll subtract 2x and I'm left with negative 3y minus 2x plus 15. And then I'm going to divide everything by negative 3. Y is greater than 2/3 x minus 5. So my slope is 2/3, my y-intercept is negative 5, and I will start down at the y-intercept, negative 5. Now let's go up 2 over 1, 2, 3, up 2 over 1, 2, 3, up 2 over 1, 2, 3. And this inequality is greater than, remember it flipped when we divided by a negative number, so it is non-inclusive. I'm going to do a dashed line connecting everything. And then I'm going to think critically about this the first time. So my y-intercept is here, and I'm told that it is greater than. So I need to shade all of the values that are greater than this point. So y values get greater as we go up. So I'm going to shade everything up above that point. If we were critically thinking about this, I would have selected a test point. So the point 0, 0, that's always the easiest one to do if you can. And when we substitute it into y is greater than 2/3 x minus 5, we get 0 is greater than 2/3 times 0 minus 5, which is greater, 0 is greater than 0 minus 5, or 0 is greater than negative 5. Because that is a true statement, I need to shade the side that has this test point. So, and make sure that test point gets included in the shading. Alright, the shading part can be a little bit tricky, so you might want to go back and re-watch the 3 graphs, watch the different methods, and figure out which one you're more comfortable with. But this is how we graph a linear inequality.